Welcome back to algebra class. Today we're going to be talking about lesson 0, exponents. Our objective for this lesson is to understand 4 basic exponent properties. First thing we need to know is what is happening when a number has an exponent. So we have x to the 5th power right here. What that is really saying is that we have x times x times x times x times x. And notice this 5 tells us that we multiply x by itself 5 times. Let's go ahead and look at our first property here using that knowledge. So our first example is 3 to the 3rd power times 3 to the 5th power. So if we have 3 to the 3rd, that means we have 3 times 3 times 3. We also have a 3 to the 5th, which means we have 3 times 3 times 3 times 3 times 3. Now we can rewrite this in a different way by simply counting how many 3's we have. We have 1, 2, 3, 4, 5, 6, 7, 8 3's, so we can rewrite this as 3 to the 8th power. And that's basically our general rule for this whole thing. So let's go ahead and do that. So we have 9 to the 3rd. We also have 9 to the 4th. How many 9's do we have all together? We have 7, so it is 9 to the 7th power. We have 3 to the 4th. We have just a 3. How many 3's do we have all together? We have 3 to the 5th power. Here we have x squared, so we have x times x. We have x to the 3rd, so we have 1, 2, 3 x's there. How many x's do we have? We have x to the 5th power. Next up, we have y to the 4th, so 1, 2, 3, 4. 1, 2, 3, 4, 5. How many y's do we have all together? We have 9, so it's going to be y to the 9th power. Our last one, we have 3 different things going on, but it's going to be the same process. We have 1, 2, 3 m's. We have m to the 4th. And we have m to the 2nd. How many m's do we have all together? We have 9, so it's going to be m to the 9th. Now, hopefully you are realizing a pattern because I don't really want to do this every single time we want to multiply a couple exponents together. There's actually a shortcut to go straight from here to here. And that shortcut, if we have exponents with the same bases multiplying each other, is all we have to do is add the exponents. What does that mean mathematically? That means if we have the product of powers, we're simply going to have, if we have x to the a times x to the b, our answer is going to be x to the a plus b. Let's go ahead and look at our next example. These ones we're having the same type of thing, except we have something on the outside. So I have 2 to the 3rd squared. So I really have 2 to the 3rd times 2 to the 3rd. Now I'm just going to expand them out like we did on our last part. So 2 to the 3rd. So I have 1, 2, 3. I have 1, 2, 3. How many total do I have? I have 6, so it's going to be 2 to the 6th power. Let's try that again. I have 7 to the 4th squared, so I have 7 to the 4th times 7 to the 4th, because I have it squared, so I have to have it twice. Now I have 7 times 7 times 7 times 7, and then I have 7 times 7 times 7 times 7. How many total 7s do I have? I have 7 to the 8th power. I have 4 to the 4th to the 3rd power, so I'm going to have 4 to the 4th, 4 to the 4th, 4 to the 4th. So I have to the 3rd power, so I got 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. How many total 4s do I have? I have 12, so it's going to be 4 to the 12th power. X to the 3rd, same type of thing. So I have x to the 3rd, x to the 3rd, x to the 3rd, x, 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 x. How many x's do I have altogether? I have 9, so it's going to be x to the 9th power. Try it again. So I have y to the 4th. I have it twice, so I have y to the 4th and y to the 4th. 1, 2, 3, 4. 1, 2, 3, 4. I have 8 y's altogether, so my answer is going to be y to the 8th power. Our last example looks a little bit more difficult, but it's really not too hard. Let's start with the one on the outside. That is a squared right there, so we actually have m to the 3rd squared times m to the 3rd squared. So now I have this m to the 3rd. I have it twice, so I have m to the 3rd times m to the 3rd. And then I have this m third. I also have that twice, so it's going to be m to the 3rd times m to the 3rd. I need a little bit more space on this one, so I have m, m, m. I have m, 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 and finally m times m times m. How many m's do I have altogether? I have 12, so I have m to the 12th. Now, many of you are probably saying, I'd rather not do all that work, and there is another shortcut here for this. And if you notice it, if we have something a power to a power, we can actually go from the very first step to the very last step. And all you have to do if you have a power to a power is actually multiply your exponents. So in order to simplify a monomial with an exponent being raised to another, we simply just multiply exponents. And that is our shortcut there. Now the power to a power property, if we have x to the a to the b, our answer is going to be x to the a times b power. Let's look at our next type of situation. Here we have 2 to the 5th over 2 to the 3rd as our first example. So let's go. We'll expand it out. So we have 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2. And how this works is basically if we have matching pairs, they're going to cancel each other out and equal 1. So that cancels out equals 1. That cancels out equals 1. That cancels out equals 1. So what we are actually left with is up top, we have 2 times 2. So we're just going to have 2 squared, and when we have nothing left on the bottom, it's over 1, but we can actually rewrite that because 2 squared divided by 1 is simply just 2 squared. Let's do the same thing on our next one. So we have 4 to the 5th. So we have 1, 2, 3, 4, 5 over 4. So when we do that, we can cancel out again. So we have a 4 and a 4. So we're left with 4 4s up top. So we have 4 to the 4th over 1, which is just going to be 4 to the 4th. Next up, we have 2 squared over 2 to the 5th, so it's going to be 2 times 2. That's over 2 to the 5th. So we have 1, 2, 3, 4, 5. We got some cancellation here. This time we have 2's left on the bottom, so our answer is going to be 1 over 2 to the 3rd power. And we actually can't do anything with that because we're dividing by 2 to the 3rd, so it just stays just like 1 over 2 to the 3rd. And I'm going to rewrite that so it looks a little bit better for you. So it is, once again, 1 over 2 to the 3rd power. Our next example, we have y times y over y times y. This one, you'll notice they both cancel out. If everything cancels out, it's just going to equal 1. We have m times m over m times m times m. These cancel. We're left with 1 over m on the bottom. Our last one looks difficult, but it's really not too bad. We have x times x times x. We have times y times y times y. We have x times x on the bottom, and we have a times y on the bottom. Let's do our cancellations. These x's are going to cancel out. That y is going to cancel out. So up top, I am left with x times y squared over 1, but we don't have to put it over 1, so it's simply just going to be x times y squared. So our shortcut rule for this one is simply to take the larger number and subtract the smaller number, and then wherever that larger number was is where you're going to write your answer. So another way to say that would be to subtract your exponents. We're going to subtract exponents. So it's going to be x is a minus b. Go ahead and look at our next example. So for this one, basically what we have is we're going to be using all of our stuff together here. So we have 2 to the 3rd times x to the 3rd. We have that squared, so we have it twice. So we have 2 to the 3rd times x to the 3rd. And then we still have 2 to the 3rd times x to the 3rd. We have that twice. So for our expanded form, we're going to write that out as 2 times 2 times 2, x times x times x. We have 2 times 2 times 2, x times x times x. Now, how many altogether 2's do we have? We have 6 of them, so it's going to be 2 to the 6th. And we have 6 x's, so it's going to also be x to the 6th. Let's go ahead and look at our next one. We have 2 squared times y squared. We have that 3 times, so it's going to be 2 squared times y squared. And we have 2 squared times y squared. So let's go ahead and write that out. 2 times 2, y times y. We have 2 times 2, y times y. 2 times 2, y times y. Now let's count our 2, so we have 6 of them, so it's going to be 2 to the 6th. We have 6 y's, so it's going to be y to the 6th. Let's go ahead. Our next one, we have x squared times y cubed. We have that twice, so it's going to be x squared times y cubed. We have x squared times y cubed. So we have x times x, y times y times y, x times x, y times y times y. We have 4 x's, so it's going to be x to the 4th. We have 6 y's, so it's going to be y to the 6th. Next up, we have x to the 4th z squared. We have that 3 times, so we have x to the 4th times z squared. And then we have x to the 4th times z squared. Let's go ahead and write that out. 1, 2, 3, 4 x's. 1. Oh, I'm sorry, we had that 3 times. All right. Z. For this example, I'm about to run out of space, so I'm actually going to assume that you would know that you basically need to write out x, and then you'd have your z's, and then you'd also have another x to the 4th z squared. So altogether, you would actually have 12 x's. So you'd have x to the 12th, and you would have z to the 6th. And I was going to run out of space. So once again, there should be more right there. And it should be 1, 2, 3, 4. And you should have 2 more z's as well. Okay, so I ran out of space. That's why I stopped there. For our third example, or our last example, it is the same exact process as we had before. We just have 3 things. So I'll let you guys go ahead and do that one. I'll give you about 15 seconds here to do that one. Okay. So if you wrote that whole thing out, to double check your final answer for that one, your final answer on this very last example should have been x to the 4th, y to the 4th, z to the 6th. That's a 6 right there, but my computer's not liking me. There you go. So x to the 4th, y to the 4th, z to the 6th would have been that final answer there. Now, how did I do that without actually showing all that work? There is a shortcut to go from the first step to the last step. You just got to know it. Basically, what you do is distribute that exponent throughout there. So raise each exponent by the power. What does that mean? That means if you have x to the a, y to the b, and that's raised to the c power, your final answer is actually going to be x to the a times c, and then you'll have y to the b times c power. That's it for today's notes. Have a great rest of your day, and I'll see you in class.